Good evening, algebra students. I've got your solutions to the second quiz of Chapter 6 covered in the last 3 or 4 lessons here. Let's get right after it. Alright, the first problem we were asked to use the properties of exponents to write each expression in this form. Essentially, simplify it, okay? So, on the first one here, because multiplication is commutative and associative, I can kind of rewrite this. Make sure to get this in your notes if you're looking for a retake. Then I can just do 2 times 4 is 8, and x to the 6 times x to the 6. You add the exponents when you're doing that. So that gives us 8x to the 12th. Alright, on B, again, I can use the commutative and associative properties of multiplication to rewrite this. I can then do negative 2 times negative 5 is 10. And I'm multiplying the x to the third and x to the fourth, and since they have the same base, I can add their exponents, 10x to the seventh. Similarly, here on C, I can divide the 72 by the 6 and also divide the x to the seventh by the x squared. Now, when you're dividing numbers at the same base, you subtract their exponents, so I'm going to do 7 minus 2 is 5, so 12x to the fifth. If I'm going too fast, remember, you can rewind, you can pause, write down anything you want to write down. Alright, again, I can rearrange all this stuff. I've got the 2 times the negative 4 times the negative 4, and the x times the x times the x, which is 32x cubed. 1 plus 1 plus 1 is 3 when you add the exponents. Negative times the negative is a positive. 6 divided by 3, and x to the fifth divided by x. So 6 divided by 3 is 2. 5 minus 1 for the exponent, so 2x to the fourth. And on F, you've got to do the exponents first. Remember, this is 2x squared, so it's 2 squared and x squared, which is 4x squared. Then I can multiply it by 3, which is 12x squared. Number 2, we're supposed to rewrite these again, simplify them basically, without using negative exponents, only positive exponents. It's just 2 over x. A lot of people chose to look at this as 1 over x. That's true. 2 times 1 over x is 2 over x. This is just 1 over 2x. The whole thing's being raised to a negative power. You can move the whole thing under the fraction or divide it by 1. It's a reciprocal of 2x. Basically. Same here for C, it's 4 to the fifth or 1024. Each one is the same thing. People left it as 4 to the fifth. I gave them credit. And then for D, again, you've got the reciprocal of x squared is 1 over x squared, and the reciprocal of y to the negative fifth is 1 over y to the fifth. It all simplifies to this. Just move the negative exponent to the top and this negative exponent to the bottom. They become positive in the process. That's it. Quick and easy. Not a lot of work to show on those. 3 here, just some more practice. Stuff is very similar to what we did in problem number 1. You can divide the coefficients and divide the x values. Subtract the exponents there. 7.6 divided by 3.8 is 2. Negative 2 to the 0 is 1. Anything to the 0 power is 1. So x squared times 1 is just itself. All we got to do is add the exponents there. And this one's a little bit tougher, I guess, but we had stuff like this in the notes. I got 2 to the y times 2 to the third, and 3 to the x times 3 to the 2x. So when I multiply numbers with the same base, I can add their exponents. So y plus 3 and x plus 2x for the 3. Y plus 3 cannot be simplified, but x plus 2x can, so 3x. So there's our answer. That's how we should have left it. A couple more here. Wow, okay, those both have the same base, negative 2y, negative 2y, so I could just do 4 minus 3, which is 1. So it's negative 2y all to the first, which is just negative 2y. Saw some people taking some crazy routes on that one. All right. On f, we're doing 3 squared, x squared, squared, and y squared. Everything in these parentheses is being squared. So 3 squared is 9, x squared squared, you multiply the powers, and y squared is obviously y squared. So x squared squared is x to the 4th. Then I can do the 9 times negative 5 is negative 45. X to the 4th times x is x to the 5th. And y squared times y is y cubed. Let's see, on G, here's how I chose to look at this, as the 4 stays right there, the x squared y stays right there on top, but this 2x to the negative 2, I'm really dividing by 2x to the 2nd. That's how I chose to look at it. So on top, those parentheses aren't really doing anything. On the bottom, they are. It's 2 squared over x, or 2 squared x squared, 2 squared 4, x squared x squared. And then simplify. The 4's cancel out, the x squareds cancel out, and you're just left with y. So all that ugly mess, a lot easier way to write it is just y. Writing these numbers in standard notation. Okay. First of all, it's a negative number, so my answer is going to be a negative number. 10 to the 4th is like 10,000. I've got 2.4 10,000s. Okay. Other people might choose to look at it as you're multiplying by 10 4 times. You multiply it by 10 once, the decimal place will move over one place. Multiply 10 another time, it moves to right here. A third time right here, and a fourth time right there. So negative 24,000. This is a very small number because we're really dividing by 10 5 times. Divided by 10 once, twice, 3 times, 4 times, 5 times. And C, remember we've got a negative number that we're dividing by 10 3 times. So the decimal place was here. We divide it by 10, it'll be there. Divided by 10 a second time, it'll be here. Divided by a 10 a third time, it'll be right there. This is the opposite. We're writing these in scientific notation. You got to keep all the digits that aren't zeros. Actually, you would keep a 0 if they're between digits, like that 0 right there. We'll get to that in a second. So 3.714 times 10 to the 7th. So I got 1, 2, 3, 4, 5, 6, 7 places. So this little tiny number, 3, about 3, would have to be multiplied by 10 7 times to equal this 37 million. Okay. Whereas this large number, relatively, 8, would have to be divided by 10 4 times to get this tiny number. Okay. So on this one, like I said, I keep the 0 in between the 8 and the 1, drop all the other zeros. And then on C, very similar to B, but it is a negative number, so we need that negative 1 right there. A lot of people left that out, but it's negative 1 times 10 to the negative 5th, which is very similar to negative 1 divided by 10 5 times. But those are scientific notation. Last problem here, we got Neptune, which is, let's fix this. Sorry, didn't do my editing properly. 4.498 times 10 to the 12th meters from the sun. Light travels at approximately 3 times 10 to the 8th meters per second. How long does it take for the sun's light to reach Neptune? So really, I want to take the distance that I am from the sun. Let's fix this too, because I didn't fix my data. Give me a second, I'll be right back. I'm back. Probably didn't even notice I was gone. But anyway, here we go. We got 4.498 times 10 to the 12th meters from the sun. I'm going to multiply that because I can travel 1 second, or every 1 second we travel 3 times 10 to the 8th meters. Not we travel that, but light travels that fast. So I'm really dividing these two numbers. 4.498 divided by 3 is 1.4993. I think there were 3 repeats after that, but I just decided to stop right there. And 10 to the 12th divided by 10 to the 8th is 10 to the 4th. 12 minus 8 being 4. That's my answer. Now, I could turn that into seconds if I wanted by, get rid of scientific notation by just moving the decimal place over a few spots. But we'll just leave it just like that, okay? It's about 14,993 seconds, and 14,493 seconds is about 241 hours. So, but that's how we're asked to leave our answer. All right, that's all I've got for you. Rewind anything that you need to rewind, ask questions about anything you need to ask questions about, and hopefully this is helpful to you. See you soon.